In this video, we'll look at solving for angles and evaluating expressions using inverse trigonometric functions. So it's always good to begin by remembering where we started in the last video. So we'll start with the definition of our inverse trigonometric functions. Then we'll look at solving trigonometric equations and solving expressions with a composition of trigonometric and inverse trigonometric functions. So remember that our inverse sine, inverse cosine, and inverse tangent, the sine, cosine, and tangent functions on the restricted domains, negative pi over 2 to pi over 2, inclusive on both sides, 0 to pi, inclusive on both sides, and negative pi over 2 to pi over 2, exclusive on both sides, respectively, are one-to-one and so have inverses with domains and ranges as follows. I won't read all of that, but take a moment to review that. Find all angles theta between 0 degrees and 180 degrees, satisfying sine theta equals 0.4. So I think it's always good to begin these kinds of problems by drawing a picture. So I've got a set of axes here for us, and let's just consider what we're trying to find, or what we expect to find. So we're looking at all angles between 0 degrees and 180 degrees, so we're looking at just the top half of the xy coordinate plane. Since sine is positive in both the first and second quadrants, we might expect to find two solutions. For example, suppose I drew this triangle where that value is 0.4 for theta, and we might have a similar triangle on the opposite side, 0.4 for a larger angle here. So as we solve this, I would expect for us to get two solutions. So sine theta equals 0.4, which means that sine inverse of both sides equals sine inverse 0.4. So sine inverse of sine, those just cancel out and leave us with theta equals sine inverse of 0.4. So if we were to evaluate this on a calculator, we get about 23.6 degrees. So that would be our first angle here. Of course, we do see that we have another angle for which we need to solve. So how do we get this other number, this angle here? How do we get that, this angle here? How do we get that angle? Well, that one's pretty easy, because if 23.6 would be our reference angle, right, like this would be theta bar, then the orange angle would just be 180 degrees minus 23.6 degrees, which equals 156.4 degrees. So the two angles that satisfy the equation sine theta equals 0.4 are the two angles that satisfy the equation sine theta equals 0.4 are 23.6 degrees and 156.4 degrees, which makes sense based on our expectation, what we would find based on our image. For this next one, we'll find the cosine of sine inverse of 3/5. So we have two ways to solve this. We'll begin by let theta equals sine inverse of 3/5. So since we're handing sine inverse a number between -1 and 1, we will get out some angle on the interval negative pi over 2 to pi over 2. So now let's draw a triangle. We'll interpret theta as a small angle, like this, where this will be our theta. And the sine of this theta will give us the opposite side, 3 over the hypotenuse, 5. We can then solve for the remaining side by the Pythagorean theorem and say that 5 squared equals 3 squared plus some other number squared, which this is an easy one, so we know that that's 4. So then by this logic, the cosine of that angle theta right here is simply 4 over 5. The adjacent side over the hypotenuse. So cosine of sine inverse of 3/5 equals 4/5. So the second method, I'll erase this. So the second method will use the fact that sine of sine inverse of 3/5 is really easy to find, right? We know that that's just going to be 3/5 by the property that f of f inverse of x just equals x, right? So to find cosine of sine inverse of 3/5, we'll first find the cosine function in terms of the sine function. To make it a little bit easier, let's just say u equal sine inverse of 3/5. So remember that in this case, u is an angle in the range of sine inverse, which is negative pi over 2 to pi over 2 inclusive on both sides. So recall from when we were writing one trigonometric function in terms of another that cosine of u equals the positive 1 minus sine squared of u. Now we choose positive because cosine in the first and fourth quadrants is positive. So we're all good, and that's a function of the outputs of sine. And in case you forgot, I can just quickly draw. These are all the outputs of sine. And cosine would be positive in all of those. So then we can substitute u back into our equation. So this equals the square root of 1 minus sine squared of sine inverse of 3/5. So that means that we should just have 3/5 left, since sine of sine inverse just gives us whatever we've handed sine inverse. So we have the square root of 1 minus quantity 3/5 squared, which gives us the square root of 1 minus 9/25, square root of 16 over 25, which is 4/5. So two different approaches, same solution. In the first approach, we said, let's let that angle be part of a triangle. And then the second side, or the second solution, we use the fact that sine of sine inverse is easy to solve for. So both approaches are equivalent, and you should feel free to use either depending on the context.